Good morning, students. So today I come with a new topic, software quality assurance, which is one of the important concept of software engineering. So in this class, I'm going to discuss about what is software quality, how it is give that assurance, and different characteristics of softwares for its good quality. So if we see quality assurance, then first, introduction software engineering. So tools, method, process, models, equality focus. So equality focus, what tools are used, what method are used, what is a process model, etc. So good quality software is always essential for us. For a good quality software is always, we hope. Then what is quality? If we see the definition of quality, quality is defined as characteristics or attributes of something, where as attributes refer to measurable characteristics, things that we are able to compare to known standards. So there are two kinds of quality: quality of design and quality of conformance. So quality of design refers to the characteristics that designers specify for an item. The grade of materials, tolerances, and performance specifications all contribute to the quality of design. But if we see the quality of conformance, which is the degree to which the design specifications are followed during manufacturing. So greater the degree of conformance, the higher is the level of quality of conformance. So now if we see the software quality, then it is defined as conformance to explicitly stated functional and performance requirements, explicitly documented development standards, and implicit characteristics which are expected to all professionally developed software. Now, in software development, the quality of design encompasses requirements, specifications, and design of the system, where as quality of conformance is an issue focused primarily on implementations. So if the implementations follows the design and the resulting system meets its requirements and performance goal, conformance quality is automatically high. So software quality assurance, so SQA. Software quality assurance is an umbrella activity which is applied throughout the software process. So it is an activity, a long-term activity which is applied throughout the software process from starting to end of the process. So software quality assurance encompasses a quality management approach. So how we maintain the good quality of the software. Next, effective software engineering technology. So software engineering technology which is more effective is applied here. Formal technical review, so multi-tier testing strategy, control of software documentations and changes made to it. So it is also a procedure to ensure compliance in software development standard. And finally, if we see software quality management the quality assurance is measurement and reporting mechanism. So software quality assurance activities is compared to a variety of tasks associated with different constituencies. Number one, the software engineer who do the technical work, and software quality assurance group that are responsibility for quality assurance planning, oversight, record keeping, analysis, and reporting. The charter of the software quality assurance group is to assist software team in achieving a high good quality product. And software engineering SEI, if you see the SEI group, so software engineering group recommends a set of software quality assurance activities that address quality assurance. And software quality assurance plan for a project. So the plan is developed during the project planning and it is reviewed by all interested parties. Software quality assurance activities performed by the engineering team and software quality assurance team group are governed by the plan. The plan identifies number one, evaluations to be performed, number two, audit and review to be performed, number standard are that are applicable to the project, number of procedures for error reporting and tracking, number 5, documents to be produced by the software quality assurance team, number 5, the amount of feedback provided to the software project team. Now, the participant in the development of project software process descriptions. The software team select a process for the work to be performed, and software quality assurance reviews the process descriptions for compliances with organization's policy, internal software standards, externally imposed standards, and other parts of the software project plan. Number two, review software engineering activity to verify compliance with defined software process. So here software quality assurance group identifies, documents and track deviations from the process and verifies that corrections have been made or not. Then audit design software work product to verify compliance with those defined as part of the software process. So here the software quality assurance reviews selected work product, identifies documents and track deviations, and verifies that corrections have been made, and periodically reports the results of its work to the project manager. So another point is ensure that deviations in software work and work product are documented, handled according to the documented procedures. So records any non-compliance and reports to senior management. So quality concept, if we see what is the concept of quality, it is concerned with ensuring that required level of quality is achieved in a software product. So three principles concerned with the quality product or quality concept. Number, at the organizational level, so quality management is concerned with establishing a framework of organizational processes and standards which will lead to high quality software. Number two, at the project level, so in this here the quality management involves the application of specific quality processes and checking that these planned processes have been followed. Finally, at the project level, so quality management is also concerned with the establishing quality plan for a project. The quality plan should set out the quality goals for the project and define what processes and standards are to be used. So Examples, if we see no two products are similar and all engineered and manufactured parts exhibit variations. So variation controls is the heart of quality control. So software reviews, if we see software reviews are a filter for software engineering process. So reviews are applied at various points during software development and serve to uncover errors and defects which can be then removed. Software reviews purify the software engineering activities which we have called analysis, designs and coding. A review is a way of using the diversity of a group of people so to point out needed improvement in the product of a single person or a team, to confirm those parts of a product in which improvement is either not desired or not needed, and to achieve technical work of more uniform or at least more predictable quality than can be achieved without reviews in order to make technical work more manageable. Now software reviews. A group examines part of all of a process or systems, its documentations to find potential problems. So software or documents may be signed off at the review, which signifies that progress to the next development stage have been approved by the management. So there are different types of review with different objective. So inspection for defect removal product, so review for progress assessment, product and process, and quality review, product and standards. So quality review, a good a group of people carefully examines part of all of the software systems and its association documentations. So code, design, specification, test plans, standards, etc. can all be reviewed. A software or documents may be signed off at a review, which signifies that progress to the next development stage has been approved by the management. So software review process, if we see pre-review activities and post-review activities. So pre-review activities consist of planning, group preparations, then individual preparations and review meeting. And finally, in post-review activities, error correction, improvement and follow-up checks. So this way we have to the review software review process. So program inspection. So these are peer review where engineer examines the source of a system with the aim of discovering anomalies and defects. So inspections don't require execution of a system, so may be used before implementations. So they may be applied to any representation of system, requirement, design, configuration, data, test data, etc. They have been shown to be an effective technique for discovering program errors. So inspection checklist. So checklist of a common error should be used to drive the inspection. So error checklists are programming language dependent and reflect the characteristics of error which are likely to arise in the language. So in general, the weaker the type of checking, the larger the checklist. For example, initializations, constant naming, loop terminations, array bounds, etc. So this is an inspection checklist. So this is software. Now to come to software reliability. So reliability is a measurement system attribute. So non-functional reliability requirements may be specified quantitatively. These define the number of failures that are acceptable during normal use of the system or the time in which the system must be available. So functional reliability, if we see, functional reliability requires defined systems and software functions which avoid, detect or tolerate faults in the software and so ensure that these faults don't lead to system failure. So software reliability requirements may also be included to cope with hardware failure or operator errors. So reliability So if we see the probability of failure free system operations over a specified time in a given environment for a given purpose. So availability, the probability that a system at a point in time will be operational and able to deliver the request services. So both of these attributes can be expressed quantitatively. Availability of 0.999 means that the system is up and running for 99.9% of the time. So reliability specification process, if we see risk identifications, so identify different types of system failure that may lead to the economic losses. So risk analysis, so estimate the cost and consequence of different types of software failure. So risk decomposition, so identify the root causes of system failure. And risk reduction, so generate reliability specification including quantitative requirement defining the acceptable levels of failures. So types of system failure, if we see different types of system failure, so loss of service, so this type of system is unavailable and cannot deliver its service to the user. So next, incorrect service delivery, the system does not deliver a service correctly to the user. So system and data corruption, the failure of the system causes damage to the system itself or its data. So reliability metrics, if we see the reliability metrics are the unit measurement of the system reliability. So system reliability is measured by counting the number of operational failures and where appropriate relating to these to the demands made on the system and the time that other system has been operational. So a long-term measurement program is required to assess the reliability of critical systems. So metrics, metrics means the units through which you can measure the reliability. So probability of failure on demands, so rate of occurrence of failure, mean time to failure, and availability. For example, probability of failure on demand. So this is the probability that system will fail when a service request is made. So it is useful when demand for service are intermittent and relatively infrequent. So appropriate for protection system where services are demanded occasionally and where there are serious consequences if the system is the service is not delivered. So rate of fault occurrence, so ROCWF, so which reflect the rate of occurrence of failure in the system. So rate of fault occurrence of 0.002 means two failures are likely in each 1000 operational time units. So two failure per 1000 hours of operations. So in this a relevant of for system where system has to process a large number of similar requests in short time. So uh, reciprocal of rate of fault occurrence is mean time to failure, MTTF. So MTTF means mean time to failure, which is reciprocal of rate of fault occurrence. So perception of reliability. The formal definition of reliability does not always reflect the user's perceptions of a system reliability. The assumptions that are made about the environment where system will be used may be incorrect. So the uses of system in an offline environment is likely to be quite different from uses of the same system in a university environment. So the consequence of system failure affect the perception of reliability. So unreliable windscreens wiper in a car may be irrelevant in dry climates. These are examples. So reliability and specifications. Reliability can only be defined formally with respect to the system specifications. That is, a failure is a deviation from specifications. However, many specifications are incomplete or incorrect, hence a system that conforms to its specification may fail from the perspective of the system users. So furthermore, users don't read specifications, so don't know how the system is supposed to behave. Therefore, perceived reliability is more important in practice. So thank you. Thank you. Today I conclude my class. Okay.